Welcome, everyone, to our Open Source at Stanford and our OpenSci webinar on peer review as an author and reviewer. Today, we have Noam Ross, who's the executive director of our OpenSci, to join us. This is actually the second webinar in a series of three that Stanford Open Source Projects Office, Open Source at Stanford, has been hosting with our OpenSci. And we intend for this to be a useful recorded resource at a later date for our Stanford community and beyond. And thank you to the attendees who are able to join us live. We are hosting this on Zoom, and there are a number of features for those of you who are here in person that you can use to connect with the panelists and hosts. There is a chat function. I believe there should be a raise hand function and a Q&A that we will continue to monitor if you have any questions as we move along. So before getting started, I did want to introduce Open Source at Stanford in case this is the first time you are engaging with our Open Source Projects Office, or our OSPO. We are part of the Center for Open and Reproducible Science. So as much as we are about open source software development and best practices in open source software, we are very much situated in the practice of open science as well. I am Francesca. I'm the technical community manager, and my colleague, Zach Chandler, who is the executive director of Open Source at Stanford, is also here joining us today. We are led by our faculty director, Russ Poldrak, and we really focus on supporting the development of open source software within the research ecosystem. Currently, we convene a community of PhD students, postdocs, research staff, faculty, but we're continuing to grow that and touch all corners of campus, starting to engage with people who may be approaching open source software for the first time, or some undergrad students, as well as continuing to support our existing community. And if you would like to connect with us directly, you can feel free to email us at opensource-info@stanford.edu. As I mentioned earlier, today our webinar with our OpenSci is the second in a series of three webinars. We held one late last year on publishing, promoting, and peer reviewing R packages. That is already available on YouTube at the Stanford Data Science YouTube channel. And this resource will also be posted on that YouTube channel. And we intend to host our third webinar in this series on long-term open source package maintenance sometime in the late spring. I would also like to remind everyone that we are operating under two codes of conduct today, the Stanford University Code of Conduct and the rOpenSci Code of Conduct. Both of these are available online if you need to refer to them in more detail. And with that, I'd love to hand over the mic and the screen to Noam Ross, who will share with us today our OpenSci peer review as an author and a reviewer.
Thank you very much, Zach and Francesca, and everybody who is here for that introduction. I've really enjoyed the sessions we've had already, and looking forward to the sessions that we are going to have. I want to just start out with a little introduction to myself, which hopefully will also prompt an introduction, something of an introduction from everybody else, because I'd like to learn a little bit about the audience that we have today. My name is Noam Ross. I'm executive director of rOpenSci. I've been in that role for 2 years. I've been with the organization for 12 years, about as long as our peer review program has been there. My background is not in computer science or software or engineering, but I'm a disease ecologist. I've become a computational disease ecologist. So I work in research in emerging diseases, but work on reproducibility within that space and disease forecasting. And I also work in a variety of projects in science and public health advocacy as well. And so in addition to rOpenSci, I have hats at a group called One Health Research Consulting, a group called Grant Witness. I do advisory for the Centers for Disease Control and others as well. And even as science, this is my second career. I was once in management consulting before. My graduate training was at UC Davis, and I've been at a variety of NGOs. I'm talking to you today from Brooklyn, New York, which is my home base. rOpenSci is an international organization. We really have headquarters is wherever somebody is, but our core staff are 6 people in 6 different countries in every hemisphere. And our community is, folks 1,000+ strong in dozens and dozens of countries all over the world. So uh, before I go on, if you can, I would love to know a little bit about who you are as we are talking here. So there is a chat available, I believe, for at least those who are in via Zoom. So if you would be able to give just a little introduction to who you are, and what you do that brings you to this event at Stanford Open Source, I'd love to know. So as example, like right here, an imaginary persona I have here is Michaela, being I'm a neuroscience postdoc and I do image processing, right? So that's the type of work I do. So if as we talk go forward, you can put a little introduction to you in the chat. That'll be really useful as we move forward and talk about and have our Q&A later. So today I'm going to talk about software peer review at rOpenSci. I'm going to talk a little bit about the origins and design of this particular program, and how it's come to be, how we do things. And then I'm going to talk about navigating peer review as an author, and then as a reviewer. We'll spend more time as an author because I suspect more of you will be authors first, but we'll get to reviewers as well. And as Francesca said, this is the second in a series. We spoke about broader platforms and different ways that we publish our packages in our first event. Today we're talking about the review process itself, and then we're going to have another event in a couple months on that post-publication long-term package maintenance for open source, which is another big part of the programming that we have at rOpenSci. So I don't want to spend too much time on it, but I think it's important to talk a little bit about the origins of this, so you have an understanding of why it's come to be that we work in the way that we work. Um, like I said, I basically came aboard rOpenSci a couple years after it started, as the peer review process was being initiated. But it is something that has developed over 12 years as a process, an iterative process, essentially, where we've gone through a whole number of phases about what we are trying to do with peer review. rOpenSci started as an organization that mostly built our packages and software ourselves. And so I was actually recruited to participate as someone who would review the software that rOpenSci staff was developing so they could get an outside perspective before they put it out for use. Essentially sort of a software engineering review process before release, essentially. And that was something that was really was the only thing we did in maybe the first year of the program. But it very quickly moved to this, what we called phase 2, because once rOpenSci started publishing packages, we had a lot of people interested in contributing to the tools that we were building, both as contributors to individual pieces of software and saying, hey, can my software be part of rOpenSci? And so phase 2 ended up being what we had called the onboarding era, in which we were trying to do some kind of quality control for packages that were going to become part of the rOpenSci collection. I submitted a package to the rOpenSci collection before this phase happened. It got sort of, before we had any kind of review. It was just sort of like, hey, I have a package. I think it sort of fits into the rOpenSci mission of connecting open science on the web. And we just sort of had this collection and we realized we needed quality control. So our first phase was trying to establish standards in that quality control process. Um, but as that process got more and more formalized, we found that for so many people, the value was not in becoming a member or having their packages contributed, but just getting the feedback. And so peer review became much more focused on process relative to product for package developers to get that feedback, and that feedback being modeled off of both software engineering based review, but also, given that our community is largely academic, based off norms and standards from manuscript or journal article type review. And that was sort of the real push for probably sort of 5, 6 years of the work. Really, uh, process as products is what we did, and that's still most of what we do. But I would say what we've done in the past few years is expand really into our current phase, where we are doing all of that, but we really also view peer review as an integral component of a community support ecosystem. So people do come for the feedback and the publication, but peer review is also the center of a whole lot of other activities that are powered by participation in peer review, be it using peer review as a mechanism for people to train and to provide mentorship, trying to develop new collaborations between people who have encountered each other in peer review, and essentially using it along with mentorship training infrastructure as different legs of having a really whole supportive ecosystem for open source scientific software developers. We've sort of arrived in this time as having a series of goals and design principles for our OpenSci software peer review that get summed up in this statement: that we want to build capacity of the developer community through this and drive the adoption of best practices. So that's what software review does in and of itself to with the community, and then to the packages themselves, improve their quality, the discovery, and sustainability. So we have these multiple goals, and our whole process tries to support all of these. And there are a few key design principles we've had from the start in doing that. The first is making sure that software peer review is non-adversarial, constructive, and supportive. Software peer review, we don't really reject, right? Everything is sort of hold until you're ready for submittal. And the goal is to be not competitive within the space, but to support uh, uh, our authors in how to make their work better. Because we want to facilitate that collaboration community, peer review is overseen but not mediated by editors. And so you have direct author to reviewer communication in the process, rather than something being sent to an editor collating it and sending it to an author. You have direct one-to-one communication through a GitHub platform. And then the whole thing is fully open and transparent. Everyone knows who everybody else is. Everybody external to the process can see the public process of the review happening and refer to it later. And so those things support each other. We think the fully open component is really important in open source. We acknowledge there are challenges relative to some areas in, say, your more traditional scientific peer review that have been addressed by, say, making things fully double blind. So you could address biases in the system that way. We think transparency is the other way to do that. Everybody knows who everyone is, not just within the process, but outside the process. We think that public component is a way of promoting good behavior. So with that as just a baseline of what we're trying to get, I want to talk about how you navigate through this process as an author. If you're a person who participates in or themselves are the lead of developing a software package that may go through peer review, what's it look like when you go through? What are the things to do to consider in your development to prepare, and how does it play out? I think it's important, just as it's important for us to have those goals in mind when we design peer review, for people to think about why they want to go through this process. We are big fans of it. We want lots of people to do it, but it's not the correct doing peer review for software or doing peer review software for us isn't necessarily the right match for every software development goal. And so there are a few different components to this. I went over a lot of this in our last meeting where we talk about um, knowing why you're doing software review really helps you determine where you're going to submit your package and when you should submit that package. The thing that we think is most valuable and most important in software peer review is getting feedback on your work from an external party to make it better, to get more eyes on it, to get an understanding of how other people would use your software. That's actually, when we survey our authors, the biggest reason why they participate and where we think we're able to add the most value. Um, you also may be, interested in making sure that you are getting academic credit and recognition. Yeah, I mean that your software can count as an academic object on a CV or in evaluation. That's an important thing. That's something that we can do, but not only we can do. And partially, it's just a matter of getting visibility and recognition and discoverability, and that's something that we do also do, but it's not the only mechanism to do it. And you do have options depending on what your goal is. So in addition to rOpenSci, there's the Journal of Open Source Software. They engage in peer review across all programming languages. They have a much broader scope, but tend to have a less intense review process. So to some degree, if you need that sort of like publication badge, but you're not ready to do as much iteration on your work, they might be a better goal. We do have a partnership with them, so you can use the rOpenSci review process to get a JAWS DOI. If your package is instructional, the Journal of Open Source Education publishes software that's specific to instructional purposes that might be useful, and they also publish lessons about software, which is a different thing. And then you have the more traditional journals that maybe software or not software focused, including, say, the methods journals. We actually long had a partnership with the Methods in Ecology and Evolution, and people might publish software really to aim at your target audience. And so for all of these, you want to think about the timeline and effort, very much the scope. Is the software a good match for the particular publication, and the audience and what the value is to both you and them. If you're looking at rOpenSci, the thing that that you'll expect that's different from other places is a much more in-depth review process, probably, than most journals and most other software journals. We have a fairly intense process designed to really improve the usability, the quality, the documentation of a software package. It is something that you're taking on a process. It's not checking a box. We're focusing on quality documentation and standards. But one of the things you get with us that you wouldn't get otherwise is support for ongoing maintenance of your package, because you become part of a community of authors that are continually updating their work, that are sharing the support and supporting each other as co-maintainers of their package.
No, I had a follow-up
Yeah.
question about, your point in
Mhm.
deciding among the software peer review options, which one suits your project best. Is there a way people can connect with rOpenSci as a sort of pre-review step to see if that fit makes sense?
Got a
Other
whole
than, of
section on
course,
that
tuning in
that
here.
we'll have later
Oh,
on.
perfect.
The short answer is we have both a pre-submission guidance process, and we have a special door for participants from Stanford and open source that we have as part of this partnership to do a pre-review consult as well.
Great. Thank
So
you.
we'll get into all of that.
Perfect.
Um, So I'm going to try to sort of follow the timeline of a review itself here, which is like not necessarily as, I wouldn't necessarily call it a 9-step process, but there are phases, not all of which are the ones that you're focusing on, of development through publication. There is that pre-submission inquiry is one of the is an optional step that's right in there for you to be able to check. But I want to focus on the fact that part of this timeline is the development process itself. If you are thinking about doing peer review, building that into the development stages of your package is very helpful to anticipate the types of things that are there. And then sort of all the process, which very much does follow sort of an academic type a process, becomes easier from there. Um, it's also important to consider what the actual timeline is. We have been doing this for 12 years and continuously working on how to make the process um, more efficient and manage our management processes to push things along. It is, we think it's faster in our experience than traditional academic publication, but the timeline is still months. So this is a graph we have. This is from our dashboard, this is a public dashboard that anyone can access about the current state of reviews, what's in a review, what's going through the process, how many reviewers have something underway, what's the current capacity, and how long does it take from submission to publication. So it's fairly typical that submission to publication is something like 4 to 5 months. Which, if you're used to the journal process, might seem very short. If you're thinking about what the release process of a software cycle, you might think as long, but that's typical. And as you probably know, if you're statistical, what's typical is never actually what to expect, right? So this is a histogram for how long in number of days it's taken from submission to final approval of packages over the past 3 years. So you can see there's typical, right? Like that bin with 150 in the middle. So, that 5 month period is what we'd expect. Most are that or longer. We do have some very long tail processes, and that's something that we really do try to manage. I would say that the biggest reason is the time for authors to do the revisions themselves, and we're happy to give authors as much time as they want to do that. You often do get a period where someone has to be like, okay, I've gotten back my reviews, but I'm going to have to put that aside for 3 months before I do a new release of the package. That is typically the biggest reason we have the longer ones. With the exception of cases where we're sort of piloting a new process, we're doing a whole new thing, and there are kinks working out. So we've managed to knock it down a little bit over time. And the biggest reason for that is the growth of the system. So when we started out, there were 2 editors, me and Scott Chamberlain. Now we have 19, I believe. And so right on the dashboard, you can see how many editors are currently engaged in overseeing a process, and how many are free. If you really wanted to, you could use the dashboard to decide, oh, a bunch of people are free. Let's dive in and submit today. So before the submission, the goal is to have a package prepared for review. But these are largely the things that one does to prepare a package for review are one does for preparing a package for release and bring it up to a certain level of quality. And a lot of what we do is provide tools that are often used by people who are not even submitting for review, but using those tools for other quality controls. So once you start aiming towards a publication, you want to check on the scope, be it rOpenSci scope or JOS's scope that you are fitting in. And part of that is going to be the pre-submission process. And then develop that package according to the standards of the venue. But the thing that I like most to talk about are actually the tools that we can provide to help you do that. So rOpenSci has a scope that has 2 major umbrellas, one of which we've done since the start and one of which we introduced in 2020. So the first pool of packages are things that cover the scientific data lifecycle. So that can be scientific data access and retrieval, data cleaning and transformation, data analysis and modeling, and data visualization, all of which are focused around specific types of scientific data. So we don't cover things that are very general data science. So if you say, I'm writing a successor to dplyr, it's general data manipulation. We don't cover that. But if you cover something to say, I have stuff designed to retrieve and manipulate data from NCAR's atmospheric data repository, that's very much in scope. So a scientific application is essential. The other side is statistical algorithms and methods. And so since 2020, we've done work where if you are implementing a package that is implementing a regression model, a machine learning algorithm, a network model, a diagnostics and visualization package. We spent a lot of time with our with our peer review board developing a set of standards specifically as to how we could evaluate those for robustness and correctness, which is a different set of review requirements than we have for ones that are general scientific data manipulation. And so we have two books, essentially, which are guidances of how to develop each type of package and the standards behind them. And I just put up the table of contents of each here for the moment of the standards package of those two books. And I'll have the links to all of them all over this presentation, which are the rOpenSci Dev Guide and the Statistical Dev Guide. And so they cover a lot of things that you might see if you're a developer in in places such as Hadley's R packages development or the data science learning community's package development guide. But the dev guide goes through things that range from what's a good name for your package to how do you write good function APIs and how do you create contributing files and documentation, licensing, testing, things along those lines that are general. And then we have the whole series of standards for statistical algorithms. And those really get into the specific subcategory because the considerations are very different between a regression package, a Bayesian package, a package that's dealing with geospatial data or time series software. And so we had experts in each of those topics contribute to those standards for the specific statistical considerations. And then there are higher level things that are specific to reproducibility testing, how you do input validation functions, things like that. It's a lot to cover, which is why we build tools to help you cover it. So one of the many tools that we have is our core orchestration for testing packages called Package Check. And Package Check is something that you can run on your own piece of software to say, how is this doing in terms of our OpenSci's submittal standards? So it has a bunch of things, but it really wraps around one specific function, package check. And if you're developing a piece of our software, it will run through everything that we have automated within our check process, which is an expansion above and beyond, say, an R command check. To check being like, okay, is the name not already being used by something else? Does it have the documentation required? Does it have the examples we require? What's the test coverage, other things along those lines, and it'll give you sort of a really top level table of contents and then a whole lot of other information. We also have it set up that you can you run one function to automatically set it up in a GitHub repository. So if you use the package check GitHub action on a piece of software you're developing, it will monitor that. And every time you push to your repository, it will have an issue that it will give the current status against our OpenSci's package checks. So this is something that we like because this is what we use when someone submits to us. This is the first thing that we run, and you'll see that in our as I show the review threads and how those happen. The statistical standards have this additional component. We have what we find are fairly novel and strict standards in this space, essentially. We spent about 18 months doing research into what else in statistical software space had established standards, right, for implementation. And it turned out to be really sparse in terms of what was out there, in terms of appropriate, things beyond sort of the highest level testing approaches. And so we wrote this series of statistical standards and realized we needed new ways to help people implement them and new ways to help people evaluate them. Um, so if you submit under our statistical algorithms program, then uh, part of what you will do is use another set of tools of ours called SRR, Statistical Review Rocklets. Rocklets are part of the Roxygen package, which is the most widely used tool for documentation in R. And what SRR does is it extends that to enable you to annotate code with guidance on statistical standards. So what one does when one's using SRR, you add little annotations to your code that gives an explanation of how your code meets statistical standards and which standards they meet. So our statistical guide has all of those standards in with codes, and you can put a annotation that says this test right here meet standard G5, the general standard for testing that, and you can give an explanation as to what that is, right? So one of the testing requirements will be that an error is raised if the wrong type of input is put into the algorithm, and you can make this annotation here. The package also has a bunch of tools to help you generate these, so you don't have to type them all in. You can give it the scope that you're trying to cover, and it'll download a list of all those standards, and you can copy and paste them into the right places. And then we use that because it generates a report that you can read and your reviewers can read for standards compliance. So this is an example from a package called our CRISP that does CRISPR genomics analysis. And both the reviewers and the authors can look through this and say, okay, right, here's the list of standards in the general category or the spatial category, right? Which ones are covered in this package and where line by line is it? So you can click on any of the links here. It'll take you into the GitHub page and it'll show you the line of code, right? That says this is the place where we're doing data type translation. This is the type, this is the place we are making sure that there's a test that the algorithm converges or something along those lines. So SRR is one of the tools we've developed for that. So the best way to help you understand what to expect in this process is to walk through a review that we have. And so I think I'm just going to, rather than give you slides, talk through the sort of the mechanistic process of it. So I'll even start. Everything starts on GitHub. We have a GitHub repository for software review. And when one submits for a review, one just creates a new issue on GitHub. What will happen if you submit an issue is you will get a big menu here of different things that you might want to do. There really are only three, but all of those are available in both Spanish and Portuguese. We have both Spanish language and Portuguese language editors and reviewers within our process. And so you can submit a package so that the review process is entirely conducted in one of those languages. We have a big South American community, and that can be done whether or not your package is written in those languages of the documentation and otherwise is in Spanish. You'll do it, but you can also have an English language documented package, but still conduct the review in Spanish and Portuguese. If it's your first time submitting, or specifically if you're submitting a statistical package, we require it. People can submit what's called a pre-submission inquiry. A pre-submission inquiry is very similar to how you'd submit a package. It's basically a practice run in which you can have a discussion with an editor as to like what are the current challenges and whether the package meets our OpenSci scope. So when you submit a package, there will be any of these types. There will be a series of questions to answer in submitting an issue. Most of them are just checking off what categories of things they cover, which is helpful for us for finding reviewers, and a little bit of an explanation. And so if you submit a pre-submission inquiry, it will look like this. both in the main review or otherwise. You'll get a response from an editor that will ask you questions about who will talk about um, who might ask you some additional questions, and they will help evaluate, okay, this is in scope, this is not in scope. And you can submit something well before it's ready, before it meets all of the standards. So you can make a decision as to whether you want to go down that road. If you've submitted a pre-submission inquiry and it's good to go, and you don't have to necessarily do so, it's pretty much the same process to submit your package to submit software for review. Once again, it's just submitting uh, a GitHub issue. You'll have a few more questions, but once again, it's mostly pasting information you already have, answering questions, and then we have some other important things such as what's your target audience, which helps us identify who we might want to review the package, right? What do you know about other packages in the ecosystem that are related? And then we have some important questions around ethics, sometimes for human subjects related work. Um, uh, and if you know that there's an issue, say, with the automatic testing and package check, you can say why anything is not the case.
And
That's it.
no,
Yes.
I know you mentioned
Mhm.
earlier that with open source at Stanford, our OpenSci can review some of our community's projects. And you did answer my question about the
Mhm.
pre-submission process. I did want to announce then to folks here and also people who will refer to this resource that if you are a Stanford project who's interested in getting connected through our OSPO open source at Stanford directly to our OpenSci and Noam for either the pre-submission process or to submit for review. The best way to connect with us on campus is to join our maintainers and contributors roundtable. So this is our community of coding leads, research software engineers, open source software devs. And it is through this community that we'll be able to learn more about your projects and connect you directly to Noam and our OpenSci through that sort of special Stanford door that you mentioned earlier.
Great. Thank you. So this is a example of a current package currently under review at our OpenSci, and when one submits, one generates an issue like this with essential metadata, just a copy of your package description, right? And then answers to those questions, such as the scope and the target audience. And when you submit for the package itself, our review bot will be the first one to reply. And so the review bot will automatically run the same things that were run in package check and give you that response. That's very helpful because you know that things are in order, and then the editor knows that things are in order too. In addition to the checks, it actually generates a whole bunch of additional information, like what are the dependencies of the package, um, basic information like how much code is there, how many authors, how many vignettes. All of this helps one scope the amount and type of work there is done in the review. And then the editors will be able to take a look at that and do that first level of triage, right? So an editor will respond, assign, or rather the current handling editor will assign the main editor, and they will go through some checks and give you a comment, right? Mostly because they want to make sure that the package is in a state that a reviewer can get it and go off the ground. So they might reply being like, a little more information in the README would be really helpful so that a reviewer can navigate around the package, right? And they'll be doing that first level of triage. But if things are going well, they will tell the bot that they're seeking reviewers. That kicks off some back end things for us that helps identify people. Um, and also enables you to put, if you want, a badge. You can put a badge on your package that will have its peer review status. If you put it on at this point, it'll say it's currently under review. I want to jump into the reviews themselves, but I want to talk about who the reviewers are that you'll be doing if you're submitting. So OpenSci has a tremendous broad community of people who participate in peer review. And the goals of our editors is to find people who are going to provide a breadth of expertise to cover the different things that are important in your tool. So you will have two reviewers assigned when you get to that stage. They generally are a mix of experienced R package developers who have software engineering expertise, particularly in our language. And we also will be seeking users of the package who have expertise in your package domain. So maybe you wrote a package that does audio processing for bird songs. If that's the case, we're going to find an ornithologist to work on the package. There'll be an ideal case where we can find an ornithologist who knows something about audio processing and R, which is that like perfect unicorn of a person. But generally the goal is to have a mix of reviewers who have both that domain experience and that engineering experience, who can give feedback as potential users of the package as well as give engineering reviews. And what are the reviewers going to do when they see your package? Well, the main thing is to realize that they're going to have the first experience that a user has. So the first thing they will do is walk through your package's documentation, like the README and vignettes, and usually before even trying to dive into the code, just try to apply that to run through the examples and apply it to their own data or their own workflows, which is really a fantastic way to get external views on how intuitive your function names and API and workflows are, right? That's usually taken as the jumping off point to evaluate things piece by piece. So that gives you an ability, when they're using a function, to read through the documentation of that function for its completeness, right? And then dive into the source code of that package. They'll be examining that source code with other support tools, some of which I'll describe later, but you'll generally have a human reading every line of code that you wrote. And they'll often spend a lot of time on the testing of the package. We have testing requirements, but you can only automatically test certain components of testing. So testing is a very big part, especially in the statistical packages where your reviewers are checking that your tests are adequate. They will take all of that and they're going to write a review that goes into the GitHub issues. But then they'll do more than just send that along. They are generally there available for question and answers and to engage in a discussion with the author. And they will often suggest specific revisions and improvements, and many reviewers, I'd say not a majority, but like it's a pretty frequent occasion, the reviewers will send their reviews as pull requests into your package. That's a pretty frequent thing that happens, where they have an idea of how to change something or know how to fix something. And rather than describe it to you, they can actually submit that as a push. So I think with that, it's useful to look at what this sort of review and discussion looks like. So here's another currently under review package, which is at the point where it's had some of that review back and forth happen already. This is specific to a package dealing with media files that are published through the Nature Media Archive. And so they've gone through that initial process, which is back and forth with the editor and getting the checks and making sure those checks are finished before it's being submitted to reviewers. But this one has had a really great series of folks writing reviews. Let me get down to this point, right? So here, Eric will submit a package review. There's a template associated with it. So you'll see a bunch of check boxes they go through about meeting minimum requirements. But the real meat of it is in this stuff. And so you'll often see a response where, here Eric actually said, here's a code that I worked through doing the package. And a lot of the comments are about interaction, right? Being like, I have a lot of trouble understanding this, and I would suggest making this change, right? It would be easier if you could set global defaults for your options, right? But then some of the kind of things that they will go through are often about, say, norms, right? Like storing your metadata here is not what one would expect. There are more standard places to store metadata, right? And then they'll show where things break, right? So here's an author saying, we need more input validation because I'm breaking and running into problems with the workflow because it's not necessarily warning me when something is wrong. So you get really fantastic reviews when people really dive in through all of this. And they might be talking about Norm. Sometimes this is an interesting package. Someone had a discussion about the licenses associated with the package. That's often an important thing. And so sometimes, as this reviewer did, they might have a question and they will throw it up to the editor for additional input. And that's when the editor will jump in. So you'll get reviews like this from two different reviewers. They will both be checking things, and they will usually have a set of complimentary comments. And when they come in, the editor will ultimately, you know, uh, give a response if the author doesn't jump in immediately, saying, "Okay, we've gotten these two," and request that the author respond. But then there's a back and forth. Everyone knows who each other is. The author and the reviewers and the editor can have a discussion about ways to solve problems that have been found or emerged in a review. We find that this process is more constructive than just having sort of one, point of communication, and it also gives an opportunity for people to highlight to develop new collaborations partially as this, which is why peer review is at the center of this larger community process. Um, there will be a response phase. Usually an author will do it like this. It's not, the formats aren't necessarily required to be so, but the authors will reply point by point to what the reviewers have said. Usually they will do this after they've made the changes to the package, being like, okay, I made this change in response to this question. I made this change in response to this idea you had. This was something that I didn't think it made sense to change. If the authors and the reviewers disagree about something, that's where the editor can step in to sort of mediate. But usually it's not a process that requires mediation. It's always a very constructive discussion. When that process resolves, then the editor will ask the reviewers just to give a final approval that the author has responded sufficiently. You'll get that from two reviewers, and we'll once again use the bot to kick off some automatic processes that turn on badging, that transfer into the published repository. And there's a checkbox of things that mostly are done automatically, but so that an author can just check on to make sure that, say, transfer the package didn't break any links. There are also options at that point. We usually ask if you want to write a blog post to help publicize your package, or if there are things you want to change in the way the documentations are published. All of this is part of that final approval process. And then all the authors and reviewers, those who are new to the process then get onboarded into our community forums and other things for authors and reviewers. And the package becomes part of the rOpenSci package collections. You can also, so it ends up here. There are a bunch of other options at this point. For instance, you can co-publish at the Journal of Open Source Software, which is a way of getting for a digital object identifier for your software. I want to talk a little bit about the reviewing side of this before we get into discussion. Our reviewers are an incredibly valuable resource at rOpenSci, and we view them as real full members of the process and the community. And we spend a lot of time and effort making sure that our reviewer community is curated and happy, and doing our best to make sure it's a positive experience for them as much as authors. I've had a lot of discussions with people in the past few years about the real challenges of peer review in general in the scientific process. And one of the things that I've concluded is that I think most publishers don't necessarily invest in their reviewers in the way that we do. And that's one of the real reasons it's so challenging to get things through peer review these days, is that the incentive structures are very challenging. And we don't do any sort of the radically different things that people are proposing, like paying reviewers, for instance. Um, but we want to make the review process valuable for the reviewers. And so we do a lot of things for that. So one is we make sure that we build those tools that generate diagnostics of packages and make it easier to do the review itself. That our editors are making sure those packages that go out are review ready, so they are easier to review, so they are interesting to review, so you're not reviewing basic things that could have been checked by anybody or automatically checked, and that's why we have all this automated process to reduce the overhead on reviewers ourselves. And then we are trying to cultivate that community. So when an editor goes out to select reviewers for a package, we are deliberately asking, uh, is there a new person we can bring into this community that we want, so we can add more to the pool and like new types of experience to it? And also, is there someone who is more experienced, which helps balance out the view and can become more experienced so we can build experience with expertise within the community? Our editors and our editorial leads are all people who have come through the process, been an author, been a reviewer multiple times. And so our goal is to continue building that pipeline of participation. That said, we really want to avoid overloading anyone. No one gets a review request more than once every 6 months, and we monitor this. So when an editor goes in, they can see when the last review request that went out to somebody was. And then we do a lot of work on mentorship. If you sign up to be a reviewer, you can check a box saying, I want mentorship as a reviewer, which means that you can have a Zoom call with your editor to help understand what's going on in the package, to go through the process yourself. Or you can request that your review be looked at by an editor before you publish it, right? Some people are nervous about putting that up. We want to make sure that happens. And then finally, the really important thing is to link reviewers and authors with a broader community. If you are brought on as a reviewer, we put you into the developers forum. That's how people make a lot of connections. And like so many things, we link our training and mentorship and other programs, and use our peer review as a way to connect people to them. So that's really important to us. Um, re Editors find reviewers in a bunch of ways. There is a sign-up form. You can go to rOpenSci.org/software reviewer, and there's a form you can fill out, say, I'm interested in being a reviewer. These are my areas of expertise. I know R, but I might know these other languages that are important. I have this academic background. Maybe you can match me to topics like this. I want review mentorship, or no, I've done reviewing for software in another location. That helps build our pool when editors are looking. Editors also, they're there because they have big networks, right? So an editor will look for people who they know with expertise in the topic. They will ask the chat room of all the other editors who they know who has expertise in the topic. And something that we're implementing right now is we are building tools to automatically find people who might have relative expertise. So we have a open source package called Package Match, and it uses language model embeddings to identify similarity packages, both on the topic based on similarities of topics in documentation, but also in software architecture. So the idea is you can put in a package and it'll say, here are packages that cover certain similar areas, but also packages that maybe are coded in a similar way, even if they're different. And the goal behind that is primarily so that editors can go out and say, well, the author of that package probably would make a good reviewer of this package. And so that's something we're excited about having. And when you submit, that'll be one of the outputs that the automatic diagnostics will pop up and that Package Match will be able to give you. The reviewers will get an email request from, if you're a reviewer, from an editor. It'll talk about what the package details are, give you some options about requesting mentorship. This is the template they're sent. Our package development guide in the backs are templates of every email that the editors use for outreach, and so this is exactly what that is. We try to make sure that we build in the friendly banter. We build in the attitude of the project to this communication. Um, and then we have, just as we have standards and guidance for authors, we have standards and guidance for reviewers. How to walk through the process, templates for you to use for review. There are even some additional tools. One of our reviewers wrote a package called Package Reviewer. I think it needs a few updates, but it really actually does help that process in that it will clone the package you're reviewing and pop up the template in an RStudio window and help that workflow for providing review. That's what the bot is for, and package check and SRR generate these diagnostics for when you're reviewing package so you can know something about the size and the structure. Package check even generates these network diagrams for you, which are helpful in understanding the architecture of a package, saying, okay, well, what are the big central functions that everything connects to, right? That may be the underlying parts of what is the API or linking to other language. This actually will, if you write a package that's in C or in Rust, it'll figure out which parts are which and help you understand the connection between the API. And so we're always trying to improve the automated part so that the human part is as valuable to both the authors and the reviewers as possible. I think uh, that's about the amount of time because I want to leave lots of time for Q&A. I do want to note two things. Starting in April, we are going to start peer review office hours. Those are drop-in sessions that will be with our OpenSci editors. We're going to start them in April, and the April one will be in North American time. Since we're global, they will rotate monthly. And if they're popular, we're going to move them to every 2 weeks as they rotate through different global, three sort of time zones globally. Um, and as Francesca said, pre-submittal review is something we have available for open source at Stanford. And so if you are part of the group, you will be able to submit a package for evaluation that is sort of the pre-submittal in which someone will be able to look over, say, this is where things are, this is what's needed to get it ready for review, and you'll be able to schedule a call for a discussion of that as well. I'd love to hear questions and comments and feedback and hear, what you think about this process to other things. And I see the question that has popped up in the review is certainly the one that I would anticipate. So we have first question I see here is, how's the peer review process changed in the era of LLMs? So we have just published our software review in the era of AI series of changes to policy in software review. This is really interesting and certainly continuing to evolve. But we have started to receive packages that are heavily LLM generated as part of the development process. And we also see reviewers potentially using LLMs as part of a tool. And there is a wide variety of both comfort and approach in that. And so we just published this post about how we are dealing with that. And the core thing about it is we are trying to make sure that LLMs and AI are serving those top level design goals. Are they on the software side, making it better quality, easier to use, better APIs, right? But then is it also improving the community's capacity to develop that software? And LLMs really enable to do that. We have one community member who, because of a disability, has had a real trouble being able to do things for a couple of years the traditional way, and is now able to develop in a way they couldn't before. And so we really value that, while we also have, there are a lot of community members, and I'll say myself, have reservations about it. So there are a few things we're starting with. our goal is to make sure that what you're evaluating are the decisions that the author is making. And so what we are doing is we are requesting that people describe their LLM usage, and part of the review is things like the LLM.txt and the like claw.md files, right? Um, so the goal there is to try to target the software, the decisions that the authors are making. Simultaneously, we are piloting what should be done with LLMs in a review. So we have some very LLM um, experienced and literate reviewers, and so they are currently in the midst of some of these reviews doing testing where we're saying this is the LLM transcript I'm using when I'm asking questions about the software base. So in a review, using an LLM and using that as part of the output. But the main thing we want to make sure is that the exchange about ideas is continuing to happen. And so we have needed to do some things. Like we have received slop submissions, as I would describe it, as in a package fully generated by AI, where the author clearly did not really know fully what was going on in the package. And we don't want to be in a state where the reviewers are spending more time with the code than the author has. Um, but this is going to change. So like this post links to sort of our, our open discussion. We're actually just about to merge the changes in the Q&A that we put into the templates, which will be where you can describe this is what AI usage we've had. But we're in the midst of having a really interesting discussion amongst our editors and authors and reviewers as to what else we want to do. So we have another question from a different Zach. I have a repository that is private that we intend to publish the package and make it public. So that is certainly something we've seen before. In some ways, I have a simple answer, but I hope I can explain it. The answer is it needs to be public for it to be reviewed by us. The nice thing that we think about this process is we are in no way gatekeeping the package. It is not required that it go through review before it's published in a different journal. You put it on CRAN, you put it on GitHub for other people to use, right? It is, optional if you want to make sure you have that badge when you put it out, or you want to put it out earlier. But both because of the public review process, right, and the tooling that we have, it does need to be public to be submitted. And the people who have navigated this before pretty much usually, they put it out. We have had things put for review in front of us after they've been on CRAN for a couple of years. Usually it does mean that you're going to be making some breaking changes to the API because you do get a lot of feedback on that front. But our experience is that this hasn't been a bottleneck for foremost. The review is worth it, and the flexibility of doing it sort of whenever in the development process you want has been sufficient for people who I really do believe in that, making sure that you have that private work period. Not everything needs to be public from day one, right? But it does need to be public for review with us.
So I just wanted to piggyback on Zach Cohen's question because this is something, and you and I have talked about this before, Noam. For software papers that are not a methods paper somewhere else, the primary publication is about some science question that they're solving in some field or other, and there's a statistical package that supports it. Um, a lot of those are like that first paper is the breakthrough. Like we're announcing this new tool to the world. Um, so it sounds like for the rOpenSci process, you kind of need to have done that first. Um, and you get the DOI for the science nature cell paper or whatever. And then afterwards, there would be this round of enhancement through the rOpenSci review process.
I mean, I would say that's one model, and it's a model that people can use. I mean, we certainly come from a place where we advocate for openness further upstream. There are definitely trade-offs between it, but we certainly tend to think that the trade-offs in opening something up for review are winning trade-offs, right? And
Yeah,
that something doesn't
I
necessarily
get
need to
it.
be. That said, um the um the uh when you do something private and for release, I think, sometimes when it comes to you describing a method in a big paper or something, right? Like that's often the case. That, I mean, my experience of those things is that's usually not the release of a tool. Right? Like it's a release, like the difference between I have an algorithm and I have something with a robust API for people to use is often a very different project, essentially.
Mhm.
So people do that both ways.
I was just thinking like,
Yeah.
some fields are so competitive that the timing of these things matter quite a lot. The obviously, from time of first publication, that's when we want everything to be as, maximally open as possible. So it's just I'm trying to wrap my head around like the staging and and how this works out. But it's probably field dependent, I'm guessing.
Yeah, I think it's very field dependent. I mean, I think it's like in the sense, right? Like, our OpenSci has long I've we've had a lot of philosophies that are parallel with the idea of, like, the software carpentry group, in the sense that, there's a whole lot of important work that is core to the scientific process in this, that is the carpentry work, that, like, the tool building, right? And I'd say most our OpenSci packages, and maybe this is because of the way we do it, but also the other way around, right? Um, the algorithm is not the central, you know, thing that people are trying to get out. Certainly, when we started the sort of the scientific data management component, right, that was very much the case. But even in the case of statistical algorithms, right, like most people publishing through us, like they're at a point, or coming from a perspective where, like, because their goal is dissemination so that the most people can make use of the thing, right? And the academic credit is a smaller component of it.
And can I piggyback off
Mhm.
that conversation to ask one logistical question and then to like relevant to the topic? The office hours that you mentioned for drop-in peer review starting April, is that on the rOpenSci website
I don't have a
yet?
fixed date yet. I will
Okay,
have a fixed date. We're
great.
just trying to get through which editors can do it. Probably in the next 10
Perfect.
days, and we will send them to you.
Okay, perfect. And so to that point, is that a good compromise situation for someone who does have a private repo to sit with
Well,
an,
certainly
okay,
yeah, you can do that, and certainly
sure.
for the Stanford folks, an individual consultation isn't going to
Okay,
require publishing
right.
publishing either,
Yeah.
right?
Okay.
It is an experiment. We are trying to
Sure.
figure out
Okay,
how
great.
people are going to make
So
use.
might be
Yeah.
that sort of middle ground relevant to at least a situation where it's not quite public yet, but with the intention of going public and then maybe going through the proper public peer review process.
Yeah.
And I noticed that Carol had a question in chat
Yep.
asking Noam if a package is written in multiple languages, for example, mostly in Python, but wrapped in our package, how does our OpenSci treat it during the review process?
So we've had a bunch of this of different forms, right? And so I would say, if the package is mostly in Python and you have a light wrapper around it, we're not the best place to send it. Because there is PyOpenSci, right? And so PyOpenSci focuses on stuff on the Python languages. And if that's where most of your work is, right, that's important. That said, we have a lot of packages that have a Python component, a lot of packages that have C and C++ components. Packages that have Rust components are actually increasingly important in the R language generally. And that is part of their review process. We will find reviewers who have expertise on that side as well, and you'll make sure, like, one of the reviewers is going to be reviewing that part of the code, right? It's a time when, like, things are going to be longer. Our automatic diagnostics, aren't focused on those languages, for instance, right? Like we have the network system is like the diagnostics thing is language agnostic, but most of it is about our specific things, for instance. And so like is a place where it ends up being a little more challenging. But we definitely have packages that have Python and Rust and C components that have been fully reviewed. But you're going to get the most bang out of a package that is more R.
And Kirill, I'll just plug our maintainers and contributors roundtable because this came up recently as an area of interest that we're probably going to have a future session on is multilingual projects and environments. So you might want to come tag along with that.
Yeah. And as Zach mentioned, many of you may have attended, right? Leia's sessions with this group as well. We do a lot of collaboration with rOpenSci. We've shared, like the AI development is a conversation that's happening across the organizations. And, a lot of the process and philosophy is shared between us as well. And so, it'll if it's half and half, that probably either will work. I mean, you can't submit a Python package with R components to us. It does have to have the R interface. But I'd love to see an example where it was hybrid enough that it made sense to sort of, somehow link with both. That'd be a neat thing to try.
Zach, I know you had a question, but wanted to let our other attendees go first. Did we get to your question?
We did. Yeah,
Okay,
it
great.
was the scholarly communication,
Cool.
workflow staging question. And I think we definitely got at that. And that was enlightening. So thanks. Thanks, Noam.
Yeah, we have had, right, like, so it's interesting. We have had partnerships with journals in the past. So Journal of Open Source Software and Journal of Open Source Education all work this way. They have the same, it needs to be an open repository for them to review. Some of the others don't, but certainly in the R space, the R journal and the Journal of Statistical Software do as well. When we worked with methods in ecology and evolution, right? We had a joint badge that you could get a software package with an rOpenSci badge if you submitted to their software and methods space. It didn't have a whole lot of uptake, and I do think part of it was this, that people are trying to sort of have the big event in their publication. But and one of the neat things that we do have with these partnerships is that for instance with Journal of Open Source Software, you get reviewed by us and then you get rapid review by them. Just someone reads their editor reads our reviews and approves on that basis.
Got it.
Well, which is really neat. But all of those tend to be, and I think this is all. Zach has a comment about Julia OpenSci. There is Julia Con, which is more of a traditional, is kind of a traditional computer science conference in design, right? Where computer scientists don't publish in journals so much as submit to a conference. And so Julia Con shares some of our legacy as well. The GitHub Actions bot that we have that manages the editorial process is something that we developed jointly with the Journal of Open Source Software, and I believe Julia Kahn adopted as well, and rOpenSci is working on adopting, right? Like we have a shared infrastructure. Interestingly, written in none of these languages. It's written in Ruby. Because that's like it was the GitHub lingua franca in the early teens when this project got kicked off.
If no one else has a question, I had something I was curious about, just, based on your experience, Noam. You mentioned on your slide that even after going through the review process, one of the sort of benefits or one of the great bonuses of going through this review process is sort of post-review support or ongoing support. What are some things that, in your experience, projects have really enjoyed or benefited from, in that post-review support that you feel like is, one of the great, incentives to go through this peer review process?
Yeah, it's neat. And we'll talk a lot about this in the next session when we talk about long-term maintenance.
Yep.
Um, I mean, the short one is community participation, which is like a fuzzy thing to talk about to some extent, but you know, at a certain point we made a decision that the rOpenSci like Slacks and forums are open to anybody who participates. So if you're a volunteer in any mechanism that we have, people join in. So it's semi-open as a forum, um, uh, which like we sort of discovered is just the right level of comfort for a lot of people. And so just like I mean, every R developer forum there is, and the devels and the Stack Overflows. And so one is just like the availability of that community is good. People, if there's something new coming down in the language, or something's going to update for a new version, like everybody is on top of it. You get it. There's we also have a maintainers newsletter that goes out with topics along those lines, right? So part of that is just like keeping yourself abreast of the flow of updates in the language and having a pool of community. We also every year we survey all of the maintainers of packages that have gone through our peer review, right? And part of that is just to understand the current maintenance status of that work. But in that is also, are there specific things that you are looking for support or expertise in? And so if we get that, we will put out calls to the community for that. And then a specific part of that is seeking co-maintainers or new maintainers. So if you're looking for, if you don't have the contributors that you're hoping to get, or you know that you're going to leave this postdoc and get a new job, and this is someone else needs to manage this, right? Having that, we're able to get ahead of that. And so we use our mentorship programs as a pipeline, essentially, to bring contributors in for new packages. And then like you'll see in our newsletters there will be a list, like there's a couple of new packages seeking maintainers, and one of our staff will be managing that process to help bring new people aboard, right? And so that's as much for us as anything else, because what happens if those packages get abandoned, people are asking us about them. And
Right.
some
Yeah.
things it makes sense to sunset, right? But some things
Sure.
it's really helpful to be able to keep up maintenance, and that's increasingly, like the frontier
Mm.
of where we're putting effort into thinking about how we design our community.
This is so interesting because this
Yeah.
is like a universal need. Like
Yeah.
there are, well, literally thousands of open source projects at Stanford, some of them very small and like don't live very long, probably something in the order of hundreds of like really impactful ones. Many of them have, are interested in like attracting co-maintainers and how do we engage contributorship. So you're so far along, you've been doing this for 12 years. You have this, this pipeline. This is could be really fertile ground for us, I think. Um, can you just, I'm going to ask you to say that again.
I mean,
So,
this is all a preview of the next session,
okay,
which we
okay.
spend the whole
I
time
will
on,
wait
right?
with bated breath for next time.
But we have both maintenance and I will emphasize that a lot of our peer review standards are about setting up a package for success in this space,
Hmm.
right? So, um, the approach to using sort of using standard community norms in the code design, like there'll be there are trade-offs people have, but like we tend to lean towards doing it the way that other people are likely to be able to read the code, even if you have sort of a preferred style, right? And some of our guidance is around that, about contributing files and developer documentation. Something we had in the stats only and are moving over to the other one is we actually request that people include a what their plan is for sustainability for packaging. It doesn't have to be
That was going to be my
it can
question.
be it can be we don't know, right? Like we just want to like put the seed in for someone to think about that, right? Like, so we know this is my thesis project, it's closing, and I will fix the occasional bug, and that's all that's going to happen from now on. There are ambitions. We're going to add a bunch of new stuff after this for V 2.0, right? And that's a little bit for us and the reviewers to know. But just as much try to seed those concepts amongst the authors
Yeah.
so they are thinking about it.
We have
I
some projects here that were massively impactful in a given field. Like I'm talking about a paper with like, 30,000 citations and like,
Yeah.
was breaking ground like maybe 10,
There's
15 years
there's
ago. and then like just kind of we didn't sunset it well. Um, it could have a new life, if it were like, reborn in R or Python or something like that. And so like I could see all sorts of ways that this could be super impactful.
Your question here is whether you need to be accepted by ROS to qualify for
Yeah.
and that is the case, right? It's interesting. We actually have a project right now with a different group called Epiverse that are a sort of a collaborative network that specifically build tools for epidemiological analysis, like in outbreak response, right? Like as much for applied public health work as research. Um, and we are sort of developing this approach with them specifically, and frankly they have hired us to do this for them, and so we are building some capacity in that way, but we need balance, right? Because it is the case that every time we give a talk someone said, oh, can I get this, right?
Yeah.
But we hope to develop it so that it can exist in other communities.
Yep. Great.
Yeah.
And not to, sort of spoil the content for the next session on long-term maintenance and sustainability of open source projects, but when you sort of, I, I think it's really productive that you are almost, forcing maintainers to think about that long-term sustainability by nature of the review process and asking them sort of to build the package with that in mind. Does that include long-term sustainability funding wise as well that you are
I mean, we don't,
asking that
you know,
that question?
everyone in this space asks that. We don't ask about, it is a thing we ask in our survey. Actually, we have a
Okay.
have
Huh.
a the only thing we ask on that front is in our survey. We ask, like, are you paid as part of your job to develop this package, right?
Okay.
Or do you do it on your free time?
Mhm.
And I think you can check all of the above. Like, I'm paid as my part of my job to work on this package. I do it in my free time, and I have funding specific for maintaining this package,
Mm.
right? So it's something interesting that we keep an eye on.
Right.
It's like we haven't really, everyone in this space is always trying to figure out how to
Yeah.
both fund and provide effort. But when we're working with this other group, like it was something like, oh, we don't know that. Like we know all these things that we're working on. We don't know what their financial stability is, and so
Mhm.
it's something that's of interest. I think some of this, it's very inherent to the process, which is just that, like, if you need another maintainer, your code has to be written in a way that somebody else can read it, and peer review forces your code to be readable. Like if it can't be read by the reviewers, it can't get through. And so you have to be able to explain it and understand it, and that goes a long way towards making it possible for somebody else to pick it up, right? And we try to
Right.
like push a little more in that direction.
Well, I want to first say thank you, Noam, for this very informative session and the walkthrough of an actual review process that was really, really useful for us to see and then have as reference in the future. I asked this last time when we parted, and I'll ask it
I forgot
again.
to push up the slides last time. I will push up the slides for you.
Oh,
Yes.
great.
Yeah.
Thank you. But if people need to, get in touch with our OpenSci with follow-up questions or get in touch with you or sort of learn more about a thing you mentioned, but we didn't get to, or if they're referring to the recording, what is the best way for someone to get connected with our OpenSci?
The best way is probably just info@rOpenSci.org. Um,
Perfect.
that goes like it does go straight to me. It goes
Okay.
straight to two other people as well, right?
Sure.
So, if I'm not around, but most likely when you hear that, you will hear back from our community manager, right?
Right.
Um, the other thing that is just like, rOpenSci.org is we try to make it as navigable as possible, but one of the things that's in there, for instance, is we actually have what's called our community contributing guide, which is
Mm.
actually like a guide to like, here are all the different things that we do and the ways to get connected with those specific projects, which expand beyond peer review to the mentorship work, to our multilingual work. As I mentioned,
Hmm.
like we do a lot of effort in making this whole thing available in more languages, which has been a big push of the past few years. But you'll see, join our community calls or our co-working sessions or any other number of ways to connect there.
Great. Well, thank you so much, Noam, for joining us, and thank you to those who could attend this in person. Thank you for your questions, and you've already heard a teaser for what's to come. This a webinar on long-term sustainability and maintenance of projects. So anticipate an invite in 2 or so months, and we hope to see you there so that we can talk in full about these topics that are clearly already on our mind.
All right. Great. Thanks everyone for joining.
Thank you, Noam.
Bye bye.